Okay, so same exact process here. We're trying to find this equation. We need to first find A, B, H, and K. Now clearly they're showing a full sine wave here. They're showing a full sine wave. On your Math Excel, it will always show you the full wave. So you never have to worry about, oh, is it only showing me half of the wave? For Math Excel, they're kind of nice to you and they show you the full wave. They're nice to you because they know that every single one of these graphs can be either written as a sine or cosine, technically. But they're going to show you the full graph so that you know, okay, yes, this is definitely a sine graph. All right, so I need to find A, B, H, and K. What is my A value? There's two ways to find it. Either look at the center of your graph and count how much it takes to get to your max, or you can take the full height of your wave and divide it by 2. So what is our answer? Yes, because the full height is 6. And also from the center of our graph, from the starting point to our max is 3. So here our amplitude is 3. Now I need to find my B value. How do I go about solving for B? What is the process? Yes, first you find the period, which is the x length, the time, the amount of length it takes to make a full cycle. So in this case, how long is our period? Notice that this has been shifted. Whoops, sorry guys. Notice this has been shifted to the right pi over 4. So I'm starting to the right pi over 4 and I'm ending pi over 4 more than pi. So in total, how long is this really? Pi. Yeah, the period is just pi. Whoa, God. So what you do is you look at the graph, right, and you see that it has been shifted to the right one. I'm sorry, pi over 4. So if I was looking at this without it being shifted, if I shifted it back, it would create this graph. So now it's easier to see, okay, if I just shift it back to where it originally was, how long is that period? How long is that wave? Pi. It's just pi in length. Just because, oh, because look, it tells you that this is pi over 2, this tick mark. So I know that this tick mark is halfway between 0 and pi over 2. Halfway between 0 and pi over 2 is pi over 4. That's why it's just shifted over. Okay, so I am going to leave that original one there because I think it is useful to see it so that you can know, even though it's shifted, it doesn't change the length of the period. It doesn't change the length of your cycle. So here, my period is just pi. How do I then find the B value? What do we do to find B? What do we know period is equal to? Over B. So to solve for my B, what you do is you multiply both sides by b to get the b out of the denominator. And then to get the pi off of the b, you're dividing by pi. So what is our b value? 2. Yes, the pi's cancel there, leaving b as 2. So I think that it makes sense because this has been horizontally compressed by a half. So the period being pi makes sense. It's half the length that it originally would have been, right? It's been shrunk down horizontally in half. So instead of the full period being 2 pi, the period is just pi. It's been smushed inward. Now, what is our h value? Has this shifted left and right? Right. It has shifted to the right. We already said it. We wrote it. It's been shifted to the right pi over 4. Right? That initial starting point is at the x value of pi over 4. So it's moved over to the right, this length right here. This is our horizontal shift of pi over 4, our phase shift. Has it been moved up or down at all? I know that I showed you what the graph would have looked like if it hadn't been shifted left or right. But yes, Jessica, look, this is not where the parent sine function starts. The parent sine function always starts at 0, 0. So this has been shifted also down 2. So our k is minus 2. You always have to think back to what your parent function would have looked like. Our parent function is that, always. And our parent function for cosine is always, I can never draw cosine as well. I don't know why. That. So now we use these values to find our equation. F of x is equal to, our a goes out in the front. This is a sine graph, so I write sine of, our b value comes next, times x minus pi over 4, that's our h, minus 2. Any questions? Okay, so now let's go back and do the other type of problem. We're given the equation and we have to graph it. So just like always, I start off by identifying A, B, H, and K. What is our A value here? Three. So that means our amplitude is 3. What is our B value? Oh, sorry, jumping. Oh no, I'm not. What is our B value? I thought it was the angle, just further from the period. Oh, there is a misprint. Look at this. Look at this. There's no X in here. Oh my gosh, there's a misprint. So we're gonna assume that they meant pi over 2 times it. So what did they want here? Yeah, pi over 2 times x. That's fine. So what is our b value? Pi over 2. What is our h value? 0. And our k value? Before we start graphing, what do we need to solve for? And what do we know period is equal to? And our b value in this case is pi over 2, which is just fine. Don't let this freak you out. What I do now to finish solving for my period is I multiply by the reciprocal. So it's 2 pi times 2 over pi. What happened? Yeah. So this has been stretched by 4. I'm sorry, horizontally by 4. Sorry. Sorry. Thinking about too much at once. So now let's go ahead and remember from before when you're trying to find your 5 perfect points, what you do is you take the period and you divide it by 4. So to find my points, I'll do it. To find my points, take the period and divide it by 4. And I get 1. So what this means is every increase of 1, you're going to have a perfect point. Your period is 4, so on my graph, go ahead. 4. Oh, yes, yes, yes. It's always 4. Always. Because if you're thinking about the cosine graph, why can't I zoom it? It still has, oh, good God. Okay. It still has a perfect point through the x-axis, uh, a minimum, a perfect point, another perfect point. There are still 1, 2, 3, 4 sections. Okay. So that means that my max and my x-axis is going to be 4, and I need to have a point every 1. So from 0, I go up 1, go up 1, go up 1. Ooh, those, I did not draw that well. And my amplitude is 3. So what this means is, and this is a cosine graph, which normally starts, my parent functions would have started at 0, 1. Instead of it starting at 0, 1, because my amplitude is 3, it means I'm instead starting way up here. And then I go down to my x-axis, and I have a low point at the next tick mark, which this is at -3. And then I back up, and then I again hit my max at 3. This, oh my gosh, could I have drawn a worse cosine? I don't know why I suck so bad at drawing cosine. It's literally just sine, just starting from a different place. And if you ever want to draw like little dashed marks to help you draw, well, I mean, actually, I'm not going to be drawing because you're virtual, so I don't know what I'm saying. But on your paper, if you are ever drawing a cosine graph and you want to help, you can create little dashed marks. It kind of helps you to visualize it. So you know, in this case, that if I were to continue drawing this cosine, I would always stay between these two, those two lines. Any questions on this? So bottom line is find ABH and K. When you're not given the graph, so like on these two examples, you need to use the B value, the period, or you need to use the B value to find your period, and then you use the period to find your perfect points. And then you draw it. And that's the process. That's it. You're done. If you don't, if you're given the graph, but you're trying to find the equation, your process is finding A, B, and K, but to find B, you take the period and solve for, and then you use the A, B, H, and K to create your equation. Again, I think this is a good stopping point, but I am, if you're still confused, on graphing, I do want to show, or at least record myself going over a little bit harder problems. So again, if you want to leave, go ahead and leave, but I will be recording myself for these two. Okay, so number 5, again, we always start off by identifying A, B. Here, where do I want to write it? I'll write it over here. A is 5, B is 2, there is no H, and there, oh, actually, maybe I shouldn't have done this. Oh, that's okay. Practice is practice. So here I need to, before I can start solving, I need to find the period. You find the period by taking the B value and you solve for the period. Oh, I was about to spell it wrong. Period is equal to 2 pi over the B value, which is 2. So our period here is just pi. That means that is going to be our max x value. That's our period. And I know that to find my perfect points, I take your period and divide it by 4, which is just pi over 4. So that means you're going to have a dash or tick mark every pi over 4. So from 0, 0, 1 pi over 4 is just pi over 4. Pi over 4. Oh my good, my brain is just not firing. Pi over 4. Then the next tick mark is going to be 2 pi's over, which 2 pi over 4 simplifies to pi halves. Then our third tick mark is 3 pi's over 4, which can't be simplified. It's just 3 pi over 4. So then you think about, to draw this graph, it's a sine, and it hasn't been shifted up, down, or left or right. So it still is starting at 0, 0. And my amplitude is 5. So that means I'm going to draw 1, 2, 3, 4, 5. That's going to be my max. And I'll also do the exact same thing mirrored on the other side. This is 5, negative 5. So from this perfect point, my next tick that I need another perfect point is pi over 4. And I have to go all the way up to my amplitude, which is 5. And then I go back down and I hit the next tick mark, pi over 2. And then I keep going down till I hit my min, my amplitude, negative. And then you go back up and hit your x-axis one more time. And you're done. Okay. Last but certainly not least, this is the hardest one, which I hope people come back and watch this, but we'll see. As always, identify A, B, H, and K. So our A value here is 4, our B value is 2, our H is key because you got to pull that B value out of your parentheses. So 2 pi over 3 divided by 2 is just pi over 3. So what makes this tricky is it means that there is a phase shift. There is a horizontal shift. So that's what makes this one tricky. We do need to find our period before we can start graphing. So, where should I slope? I'll slope down here. Our period is just 2 pi over our b value, which in this case is 2. So again, our period is just pi. Now the reason why this is tricky again is because we have a phase shift. We're shifting to the right pi over 3. So I can't just boom put down pi here because that's not really where this graph is ending. It's been shifted to the right pi over 3. So what you have to do is first you can draw how much it's been shifted. Shifted over pi over 3. We still find the perfect point the same way. You still take your period and you divide it by 4. So pi over 4. This means you need a new tick mark, a new point, every pi over 4. So what you have to do is you have to take pi over 3, your horizontal shift, and instead of just increasing by pi over 4, it's not as easy as that. You have to add pi over 4 to pi over 3. And we're going to do that. In order to add those together, we have to have a like denominator. So the least common multiple of 3 and 4 is 12. So what you're going to do is you're going to multiply pi over 4 times 3 over 3 to get a common denominator of 12. So this becomes 3 pi over 12. And we know technically pi over 3, I'll write it for you. Pi over 3, to get it to have the same denominator, we multiply by 4. So that's actually 4 pi over 12. So we have to ask ourselves, if I'm adding pi over 4 to pi over 3, I'm actually adding 3 pi over 12 plus 4 pi over 12. So 3 plus 4 is 7 pi over 12. That's our next tick mark. Then I keep going. I add another 3 pi over 12. So 7 plus another 3 is 10. That's 10 pi over 12. That simplifies down to 5 pi over 12. Then I add, oh, no. 5 pi over 12. Then I add another 3 pi over 12. So that was 10 pi over 12, plus another 3 pi over 12 is 13 pi over 12. And you're done. You found all of your big points, all of your tick marks. So then the rest is super easy in comparison to that. That's the hardest type of problem you'll get, is because of that silly phase shift. You have to find the, which I don't know how they're going to ask you to do that on math Excel. It might be easier than having to actually do it by hand. We're having to do here. But we have to take into account our amplitude, which is 4. So that means that my highest point is going to be this 4. My lowest point is going to be -4 because I had not moved it up or down. It is a sine graph, so we start at my original start at 0, 0, but it has been shifted to the right pi over 3. So my initial point is actually here. Then I go up to my max. I go back down to my x-axis. Ooh, did I forget? I didn't do enough. I didn't do enough tick marks. That's fine. Then I go to my min, and I have to go back to the x-axis. So we do have to finish finding that last tick mark, which is just 13 pi over 12 plus another 3. So that's 16 pi over 12, which simplifies to 4 pi over 3. Then you connect your points and you're done.